Hello everybody, it is July 2023 and here is the second video as promised on the scientific method. In the first video I talked about our publication in energy and environment, which you can find, like all these papers, you can find in stallinga.org, and I will put a link below here so that you can easily click on it. I forgot to mention some important information at that time. That is that this research was not funded by any grant. It received no funding whatsoever apart from our salaries at the university where we work, nor are we members of any climate committees, or are we linked to companies or NGOs, financially or otherwise. This is an independent opinion that does not necessarily represent the opinion of our university or of our government. Quite to the contrary, our government and our university are strongly opposed to these ideas. And that one was in energy and environment. And this is actually all our papers. You cannot get funding on trying to debunk the global warming hypothesis. Simply there is no career for any scientist involved in it. All the research that presented here by me is paid from my own pocket. Now today I'm going to talk to you about the second publication that was based on a conference in UFA. And this is Mr. Einstein, a picture that I've drawn based on the famous photograph. And that one was in UFA. It's I'm not sure where it's published. Maybe you can find it by this number, but don't forget you can find it also here in stallinga.org, like always. And that one, what I'm going to talk about now is the state of science in 2014, and I'm also going to talk about another paper that is about the consensus that I will show you then in a moment. So let's delve in. The two videos here, they are about the scientific method. That what is it, why is it important, and what are the components, and most important, because this is all about our research about the climate investigation, is science actually used in climate research? And as was shown there, and as I will show here again, no. The scientific method has some 4 or 5 points, depends on how you see it, and they are sinning on all these 5 points, and the entire research endeavor of the climate science, the general climate science as presented by the IPCC, the Intergovernmental Panel on Climate Change, a political institute, is non-scientific. It is 100% political. And I will also delve here a little bit into how society works and how universities work nowadays. Basically, what we can say, what I said in 2014, is science used? No, science is dead. And then I always, then very optimistically, normally I finish this phrase then with another phrase saying, long live science, because you cannot kill science ever. The idea is, what is science? Science is that which uses the scientific method, and that of course is then a self-referential answer, and that's not very nice. So we're going to now to explain what is the scientific method. So first, try to understand that a scientist tries to understand the world. It is not trying to solve problems in the world. Solving problems is what you do in engineering. That maybe the science that was was discovered or found before, that one may be useful in solving problems. So an engineer takes the results of mathematicians and scientists and solves problems of society. And also in the way in between there is the technology that can be used. So the scientific method is what we're going to talk about. Science is also, it's not calculating yourself into your stupor until you get what you wanted when you started. Science is exactly the opposite. Science is racking your brain until you cannot find any more reasons why your ideas could be wrong. So that is the scientific method. The scientific method, the ones I like very much, the book of Richard Feynman, The Character of Physical Law, but also it's famous by, of course, by Karl Popper's work. He is a science philosopher, and he describes this also very well. So it has now, in the previous video, it had 4 points. Now I spread it out over 5 points. And once again, I forgot here to mention something very important, which actually it's intrinsically said in the first point, but it has to be stated again. Science is about the real world. So mathematics is not about the real world. It is a virtual world that has been invented in your head, and then you do reasoning within that virtual world. So you have some axioms, and on base of the axioms you can say, like, if these axioms are true, then this and this and this is true, and you can prove things like that with absolute certainty. That is mathematics. Mathematics can prove things with absolute certainty in the virtual world. In the real world, science is about the real world. So point number 1 is that you do data acquisition. So you measure the world, you observe the world. And then based on that you get a lot of data, and you do reduction of the data, deduction, induction, to lead to an hypothesis. That's a magic word that you hear quite a lot, an hypothesis. An hypothesis that can explain all the data that you have been gathering. So then the second part is that you, as the one that invented that thing, that came up with that hypothesis, has to spend effort on finding out where the model fails. You have to design experiments to show that it doesn't work. Imagine that I have once again that I have an hypothesis, and I say that the current in whatever transistor cannot be more than 10 amps. Then I must design an experiment to try to observe 20 amps. It's no use if I am only going to find, you see, 5 amps, oh, 3 amps, oh, 7 amps. You see that I'm right? No, you should spend time on finding out more than 10 amps. Or in other words, this is what is called a famous word, another famous word from the scientific method is falsification. You have to, in other words, we are trying to prove ourselves wrong as quickly as possible. It's called falsification. It is of the type, if my model P is correct, then Q is not observable. And then you're going to observe Q. You're going to try to observe Q. Therefore, if you observe Q, model P is wrong. Falsification is the search for Q. What they are doing is, and that's a logical fallacy called affirming the consequent, is if model P, then observable Q. Because we now see Q, therefore our model P is correct. To show you what I mean is, they say, for instance, that we have global warming because of the greenhouse effect from our carbon dioxide emissions. And they say, like, well, if our model is correct, then the planet will heat up. And now we are inundated in social media, also social media, by all the foot soldiers of this kind of non-scientific ways. Is they say that, you see, it's warming up. You see, it's warming up. And that is not the way that they should be doing this. It doesn't matter if this is consistent with their theory. They should try to look where it's getting colder. You can never use this as an argument. It's warming up, therefore we are right. It's warming up, therefore global warming is correct. Or in other words, a hypothesis cannot be proven correct. It may only be proven wrong. And that is, yeah, let me then continue like this. I will come to this in a moment. Here's what's written on the sideline. The example is the global warming. The temperature increases, therefore global warming is true. That is affirming the consequence, and that is wrong. Part number 3. The creators of the model should convince the reader that it is the only model. Basically, you can work out where your own model fails, and in the meantime you can also show that the other models are the other hypothesis. Sometimes I use the word model and hypothesis. Hypothesis is a little bit better, but it's a difficult word to pronounce. So sometimes I will say model. So the you show that your own model hypothesis is wrong, trying to do it, and you have to do is to show that the alternative explanations, that they are wrong. So you can spend effort on both of these. So did they do this? To give you an example, is there, for instance, for the global warming, is there an alternative way of explaining why the planet is warming up, if it is warming up? The answer is yes. It is. The works of Svensmark, which is based on the solar activity, the magnetic fields and so on. Well, I will not go into detail, but that seems a very reasonable model to explain the global warming. And nobody has ever tried to show that this is wrong. So they didn't use the scientific method showing that Mr. Svensmark is wrong. I also took a look at it and I cannot see where Mr. Svensmark is wrong. While you know our videos, maybe, or not, then go to stallinga.org, because there are the links to the videos. We have shown already more than enough that the model of the global warming through the greenhouse effect, that one can basically be debunked. So that is then they should show that it's the only model that can explain things. And they then, let me see, where am I now? Now I'm at 3. We know our model is correct because it can explain the data. That is not how things are done. Number 4, the model should include a verifiable prediction of an event happening in the future or something that is not done yet. It cannot be that you're only predicting, explaining the past. That is called a retrodiction, and retrodiction is then you're always going to do a Bayesian adjustment of your model, which is also not allowed. Then you have to do something. If tomorrow it is not warmed up by the 2 degrees that I predict, then my model is wrong. And the stronger, the easier it is to get such data. So if you, for instance, say if tomorrow it's not warming up by 1 degree, my model is wrong, then your your hypothesis is actually stronger. But if you say like, yeah, you can prove my hypothesis wrong if tomorrow it is not 150 degrees warmer, which it's technically that is a way to debunk my hypothesis. Of course, you know that this is then a very weak hypothesis. The easier it is to debunk the hypothesis, the stronger it is, as long as it is not debunked. So this is not what they did. They basically do the way of retrodiction and a Bayesian adjustment. They said it would warm up, and then it didn't warm up, and they adjusted their model to include that now to give reasons why it didn't warm up. That is not allowed. Number 5. Other scientists can repeat the presented work in so-called replication, and at that moment the scientist that has done the previous 4 steps or 5 steps, meaning it also did the real world, of course, they should present then their case, saying exactly what is their hypothesis, on basis of what data it is reached, and what is the reasoning behind it, the logic steps that led to this hypothesis. So if they don't do this, then the work is also not scientific. And this happens a lot because what they did, I showed this in the previous video, they basically make a finite element calculations, dividing the world in millions of tiny space cells that are then linked to each other through some kind of parameters. And they themselves do not even understand their own work anymore. They cannot explain the logic behind it. And in there are parameters that they don't even know themselves. They cannot explain. These are just fitting parameters. And then it is of the type, well, I can predict the past, so it must also be that I can predict the future. Well, that's not how it works. As we have seen, when they did in the previous years, they did Bayesian adjustment, that when their prediction by this method failed, and we predict that it will fail over and over and over again, they constantly keep adjusting it, saying, yes, we can now again predict the past, and this is our prediction for the future. And in a way, you're not allowed to look into this prediction. You don't know what's going on in the computer, and they will not tell you. We have to trust them. And as shown, trust is not part of the scientific method. Skepticism is part of the scientific method. You have to basically show that you did a job well done and not hide any facts. they did hide facts. For instance, they were hiding the fact that in the correlation plots made famous by Al Gore's movie An Inconvenient Truth, they showed the correlation between carbon dioxide and the temperature. But what they did not show, so they were missing out here, or they were sinning in the fifth element of here of the scientific method, they forgot to tell you that actually carbon dioxide is lagging behind the temperature. And they cannot explain it. Because that would be that the cause is coming after the effect. And once again, is that the only model that can explain the correlation between carbon dioxide and temperature, the greenhouse effect as they call it? No, it isn't, as we have shown in our videos that I've already posted, and which you can find in Stallinga.org. There is another model that can explain the correlation between temperature and carbon dioxide, namely Henry's law, that when you heat up the oceans, the gases are coming out, so when it's getting warmer, you get more carbon dioxide in the atmosphere. Not it gets warmer because you have carbon dioxide in the atmosphere, but you get warmer, and then later, about 700, 800 years later, you will get carbon dioxide in the atmosphere. You see, they sinned then on not showing that it's the only model, and they sinned on that they forgot to tell us that carbon dioxide is lagging behind the temperature. That's already two sins. On top of that, they constantly adjusting the models, and they never make a prediction that can debunk their data. And it is getting even worse. They say that basically now with that extreme weather events idea, they now basically say that any event in the weather is a proof of global warming. And that means that there is nothing that can debunk the global warming ideas anymore, and therefore the entire idea of global warming is non-scientific. If it cannot, I should not point out this, if it cannot be shown wrong, then it is not scientific. Okay, so more comments. A vague model cannot be proven wrong. This I already told you also in the previous video with the feedback factors and so on. Models that do not produce any clearly testable predictions are not scientific. I already told you. Bayesian adjustment, this is not allowed. A lot of published research, apparently it's not only about global warming, but a lot of research is not meeting this scientific criterion of model uniqueness, and actually the other elements, other points as well. That's why I concluded in the beginning science is dead. Here, this is about Occam's razor. If there are two models that can explain the data, then the one that is simplest is correct according to Occam's razor or Saint-Exupéry. And the fact also in modern science is that nobody's doing replication of other people's science anymore, because doing replication, it takes a lot of time and money. And the best thing that I as a scientist can hope to achieve is that my colleague will get a Nobel Prize, because nobody will get the Nobel Prize for proving the colleague correct. That's unfortunately how it works. So then we basically say, once again, as I said here, in 2014, science is dead. And we will get to this dude in a moment. Basically, science is dead. How can it be that we wound up in this state? Well, in our opinion, it is like this, that society has demanded that science is somehow useful for society. Actually, the European Union had a scientific program which is called a knowledge-based economy, meaning that all knowledge should be in some way, one way or another, should be profitable. And science, as we said again, science is not about profitability. There is no such thing as a truth that we will make into a lie just because it makes profit. That's not how science works. And to show you, imagine, now I come back to Mr. Einstein, that imagine that Mr. Einstein in 2014 or 2023, imagine him writing a project proposal. The committee that decides about funding or not of this project will basically say to Mr. Einstein, that's all very well, Mr. Einstein, but what about the milestones and deliverables? Or in other words, where is the profit of your research? And then of course you would say like, well, yes, it is relativity theory. It's beautiful. Doesn't matter, it's beautiful. How much money can we make out of it? What are the products that are coming out of it? Are you going to write, I hope you're going to write papers at least about this, and people will get a PhD. Oh, okay, so then if I need a PhD, if I have to promote, then basically what I will do, I will just discover things that are already known. So Mr. Einstein would be a complete and utter failure in 2023. But if we want to use science to solve problems in society, that is technology, and even more, it's engineering. Yes. So to give you an example, I was fortunate to have worked in the University of California at Berkeley, but now when I read their homepage about how science works, I was a little bit let down, so to say. First, I found I didn't have it written here. I think they said there. First of all, is that science is everything that can be taught reliably, and I don't know what means reliably. What means teaching reliably? That for me sounds religion. I can make a religious idea and then start presenting it, and it's probably very consistent. I can make it sound very consistent, and I can make it actually also, I can teach it to others reliably, for what it's worth. I don't even know how to measure reliability. I don't think there is an SI unit that measures reliability. So reliability is something in your head and therefore of mathematics. It cannot be measured, therefore it's not part of science, reliability. But this is what they said. Science is everything that can be taught reliably. I tend to not agree with this as a scientific philosopher. But then they wrote also in exact words, they said these three things. First of all, exploration and discovery. So that is basically, I would put in brackets myself, I would say that's research. And yes, why not? That is the part. They didn't say it, but that would be our first item. Research, measuring reality, and coming up with an hypothesis. So I give them the benefit of the doubt. Exploration and discovery, yes, that would be part of science. But then there we go. There starts a problem. Benefits and outcomes. So once again, this is that it should make profit or at least solve problems in society. That is not science, that is engineering. So by this sentence, the University of California at Berkeley has become the technical high school of California. Because together with that, there is a difference between engineering and science. Engineering and technology on one side and science on the other side. Is that now they start restructuring all universities, and or I should say, they think that this distinction is not there anymore, that all engineering is also science, because it is as complicated as science, and science is a much more sexy word than engineering. So they have given all engineers the title of PhD, which is even funnier, because then the PhD, which represents science, you would say, is called a philosophical degree. And most of these people that are engineers, they never had a single lecture of philosophy in their lives. But this is then what they did. And then they turned all universities into technical high schools where they're doing engineering, and then call all the universities and technical high schools, they call them universities. So this one, benefits and outcomes, the relevance to society, has turned the University of California at Berkeley into a technical high school of California at Berkeley. Nothing wrong with engineering, but don't call it science. And don't call yourself a university if you're out there to solve problems, because that is a technical high school, that you educate people to work and make the world a better place. And the third point, which is there, community analysis and feedback. Well, very nice. That is peer reviewing. So you have to do society. You have to create links to your colleagues somehow, that you have to make social networks. And dear people at the University of California at Berkeley, that is not science. That is politics. That you're going to make peer reviewing and things like this. This is all politics, that you make a community. Science is not because you're part of a community. Science is because it's the truth or not, and not because other people like what you're saying and that you get this thumbs up and things like this for your statements. It is about if it's true or not. community analysis and feedback to create a society that is politics and is not what we should expect from a scientific institute. Science has no relevance to society, or not intended to have relevance to society. Yes, and in nowadays things will tend to be proven correct. That is the problem with this. Tend to be proven correct as long as they make enough money. So the truth is in the financial profit that you can get of it. Relevant society is like everything else expressed in monetary terms in 2014. And once again, technology has benefits, science does not, or is not intended to, not necessarily. Okay, so let's take an example of this, which is called the so-called consensus. As you already know, you have heard about this, that they say, well, there's a consensus that of the global warming. But a consensus is not a scientific argument. Once again, let me show you here. So where does it say here? Here we have this 5 points about science. Well, nowhere does it says that we should have a consensus for the truth. It actually says quite the opposite. Where do I have it? Or was it in the other one? That 1 million pieces of facts that are consistent with the hypothesis, they don't prove a model, this hypothesis correct, but a single piece of information, of data that is inconsistent with the theory, with the hypothesis, proves the hypothesis wrong. So therefore also a consensus, the fact that 1 million people have 1 million facts against you, against your theory, it doesn't matter, in favor of their theory, it doesn't matter anything, that doesn't prove their theory wrong. But if I have one fact that goes against this model, then the model goes wrong. So I can be outvoted by 1 million to 1, it doesn't matter, it will be the theory, the hypothesis will be debunked. And there, of course, there are famous examples. We already mentioned Einstein, which was going against the absolute certain hypothesis that Mr. Newton was right. We thought we knew everything and it was game over. We don't have to study, we don't have to do science anymore. We know everything and we have to, I guess they said, we have to teach it reliably or something like this. And an even more famous example is of Mr. Galileo, who said that the Earth was rotating around the Sun, and he was actually had to take back his words. But then when he died, he said, I don't even know how to pronounce this, but he said, "Eper si move," or in other words, and still, I insist, it moves. And this made him famous. Even nowadays, we call Galileo famous. But in 2014, we suddenly say that the consensus is something that is heroic. So what has happened? Why do we think that the people that were loners in the past, they were heroes, and now we say that you have to align to the consensus and then you're a hero? That is not scientific. But I'm going to now show to you how a consensus of something that is not necessarily true will be constructed. And this was done in another paper. I have it here. So I will talk to you in a moment. But I will show to you that this is a positive feedback. Our peer reviewing is a positive feedback system, and it works with these 3 points. First, for peer reviewing, if somebody sends a manuscript, referees are selected on basis of their publication record. So if you have more publications, you have more chance of being chosen for reviewing. So that is then, you can already recognize, you can already smell that something is then going wrong in this, that it has positive feedback. And as we know, as I also showed in the previous video, positive feedback can go out of control. We can have tipping points and so on. But the second part is that by cognitive bias, referees are more inclined to accept papers that confirm their belief than papers that go against it. Everybody is in some way, one way or another, in some amount or other, is actually having a cognitive bias. It is very difficult to actually be completely neutral when being a referee. So this happens, and it doesn't have to even happen by everybody, but as long as on average the referees have a cognitive bias and are more inclined to have papers that are confirming their own beliefs, then this system of positive feedback will work. And actually, if we want to accelerate this, we can do that. Authors do not have enough publications, they will not get funding and they will lose a job. And I will show in a moment that then the consensus is constructed even much faster. Authors with this is the result. Authors with controversial ideas see their publication rate peter out and removed from refereeing, and then they cannot have their cognitive bias can then not invert the consensus at all anymore. It's impossible then, once the consensus is established, to ever get out of it, and this is exactly what happens. Now, it's very difficult to find a referee that will listen to somebody that says that global warming is nonsense. But global warming is nonsense. Anthropogenic global warming is nonsense. After a while, a controversial idea cannot be published nor studied, and then basically we have a consensus. Let me show you how this works. Here's this paper in Monte Carlo Methods and Applications from 2015. Once again, you can find this in stallinga.org. The paper is called Consensus in Science, and I talk here once again, this is more or less the same time. This is once again a talk about the scientific method, and then I talk about these points about how you have this positive feedback, then about the mathematics with which I will not bother you. You can read it, you can actually solve this thing analytically, but much nicer is to do it by Monte Carlo simulations. You take a random set of random scientists with random beliefs, and then you let them write papers, random papers, of course confirming their beliefs, and they will be sent randomly to these random referees. And then what you will find that imagine you have a subject A. You can either have that A is true or that A is false, so that would be not A. So once you start with that you're off equilibrium, for instance, that here it was 70% of the people think that A is true. Then after a while you go into saturation. Positive feedback leads to saturation, as we also know from electronics, that it goes into 100%. It goes after a while to 100% the consensus on this subject. But if there was only 30% believed A to be true or 70% believed it to be not true, then you go to a consensus of A not being true. It is just a simple feedback system. And that is, this simulation is without scientist elimination, so people continue to get funding, but simply they do not publish. And if you now remove funding from people that do not publish, then it goes much, much faster that you get a rapid consensus if funding is based on publication record. And this is actually the system that we have. We have this positive feedback peer reviewing system, and we have a system of funding that is based on somebody's publication record. And then you get very fast, you go into consensus, and there is no way whatsoever ever scientifically to get out of this consensus idea. Even if the consensus is nonsense, you will never be able to get out of consensus. So why do you fund research, scientific research that can only prove that the consensus is right? It is complete and utter waste of money, because you can never ever ever break this cycle ever again. Okay, so that is in this journal Monte Carlo Methods and Applications in 2015, Consensus in Science, the Department of Information number, or look at it in stallinga.org. I'm nearly now at the end of this video, and what researchers do is basically technology improving constantly the scientific consensus. This is a reduction in intellectual diversity and is further exacerbated by standardization of university courses around the world. So an example is our Bologna Treaty, where all courses in the European Union are basically standards, and they are completely bureaucratic. We have learning outcomes and skills that are being mastered and so on, and they're all basically educating people to think alike. We have now wound up in a situation similar to the state of things in the beginning of the 20th century, namely the illusion that everything is known. Remember, we thought that Einstein had the final word, and we now can only basically implement and make the world better, because scientifically Newton had the last word. And remember what happened then? we got a complete and utter upheaval of the scientific ideas. So it might well be that we're again on the eve of such a very much scientific upheaval. All the signs are there, and this doesn't only apply for the climate research, but it also applies to things like Big Bang or the black holes. All these scientists, which are pseudoscientists or even fraudsters, they're constantly busy proving the black holes, this beautiful image of the black hole, where they spent petabytes processing petabytes until they found what people thought would be the image of a black hole and things like this. Or everything is constantly that we have to prove that Big Bang is right, we have to do gravitational waves and things like this. Only all the time about proving Higgs boson, which some people call the hoax boson, because they didn't try to find out where the Higgs boson doesn't exist, but they tried to find out what are the parameters of the Higgs boson, and then they found it. This is all seems all to be part of a way of proving things that we already know, to add, to reinforce the consensus, and that is not how things should be done. So we summarize the appalling state of science in the 21st century, and I expect now that we're on the eve of complete upheaval in science. All this work, all the science in the climate is not paid by anybody. We are completely independent. We're not paid by oil companies or NGOs or other of these things. It is not supported by our government, other than that they pay our salaries as professors at our university. So I hope you enjoyed these 2 videos about the scientific method, and that you start understanding a little bit how things work in this world. Thank you for your attention.